This time we're supposed to convert the rectangular coordinates to polar coordinates. But before we are going to talk about complex numbers and rectangular and polar form, we're supposed to just get back to basics. We have simply point, right, in the first quadrant of the XY plane. So let's draw this first, okay? We have simply XY plane, which is also called complex plane, and this is the x-axis, this is y-axis, this is negative y, and this is negative x. Okay, right now we are talking about simply just XY plane, and let's find this point. We have 4, so my x is equal 4, 1, 2, 3, 4, and I have 2. Y is equal to, so I have 1, 2, and this is nothing else, just the point which we are looking for. Okay, this is my point. There are two ways to navigate this point. We can navigate this point by the rectangular coordinates. This is basically what we did. Or there is another way to find this point by knowing the distance between the origin and this point, okay, and the angular position. All right? If you know the angle and the length of the phasor, you can hit this point also. So simply we can say that you can find the same point using two different methods. Now we're supposed to convert the rectangular form to polar form. Anytime we talk about the coordinates like x, y, or real and imaginary coordinate, we talk about the rectangular form. Anytime we talk about polar form, we are going to talk in terms of the magnitude of the vector, the length of the vector, and the angular position, angle theta. In order to find the length of the vector and angle, we're supposed to realize that we are going to deal with the right triangle. This is nothing else, just the right triangle. Okay? Now, this side is my y side, okay, of the triangle because it's parallel to the y-axis. This side of the triangle is my x side, which is simply, part of my x-axis. That's why I call this x. Now, this side is nothing else, just hypotenuse. I call this small r, or lowercase r. In order to find the length of r, okay, if I want to find the length of this phasor, I'm supposed to use the Pythagorean theorem, which says that r squared is equal x squared plus y squared. If you want to find r is equal square root of x squared plus y squared. So if I want to find the length of my phasor, I'm supposed to simply substitute x and y by these two x, y coordinates. So I'm going to have r equals square root, open parenthesis, and I have 4 square plus 2 square. Someone can ask why you are using the parentheses. I'm just preparing you for using the calculator, okay? Because many students make mistakes because they enter the data into the calculator without the parentheses in the right places. That's why most of the time they fail the test. So make sure that you are going to write the parentheses just in order to get used to it. So r is equal, and we have square root, and if you are going to simply raise 4 to the second power is equal 16 plus 2 to the second power is equal 4, okay, you are going to end up with square root of 20. And square root of 20 is equal 4.47. Now, you are not going to always, let's say, raise, let's say, x coordinate to the second power and y coordinate to the second power. You are going to simply just use calculator, find the square root, open parenthesis, 4 to the second power plus 2 to the second power, close parenthesis, and press equal, and you will get the answer right away. But, you know, at this problem, I just did everything step by step. So, but keep in mind about the parentheses. They are very important. Now, we have the length of the hypotenuse. Next, we're supposed to find the angle theta. You're supposed to remember the formula for tangent, right, of the right triangle. Tangent, in this case, angle theta, is going to be equal opposite side over the adjacent. In order to find angle theta, we're supposed to find the inverse of tangent. Theta is equal inverse tangent y over x. And this is the formula which we are going to use in order to find angle theta. So we have theta is equal 26.56 degrees. Okay, so this is my angle theta. We found the magnitude of the phasor. We found the angle theta. So we can say that my polar form, which looks like R angle theta, is equal to 4.47 and angle of 26.56 degrees. And this is my polar form, and this is basically the solution to my problem.